Okay, let's unpack this. If you manage a large facility, maybe a data center, one of the biggest headaches isn't always the main system itself, it's the wiring.
Oh, absolutely. The sheer complexity of it.
Exactly. So today we're doing a deep dive on a piece of hardware that's really designed to eliminate that cable spaghetti. It's the NTI E-DI16DOR16-V2 digital input-output expander.
And what we really want to zero in on is the ratio. Because this one device, it simplifies everything by handling up to 16 digital sensors and 16 output devices.
So 32 connections total.
32, yeah. And it does all that using just one single standard RJ45 sensor port on the main NTI units, like the E2D or the E16D. It's not just an accessory. It's a simplification layer.
Right. So let's start with the input side. This unit gives us 16 separate screw terminal pairs, and they're ready for standard dry contact devices.
Things like flood sensors, smoke alarms.
Security switches, yeah. Anything that just gives a simple on-N or O-off-F signal.
Right. And critically, these inputs are, they're built to be resilient. They're what we call potential-free.
Okay, what does that mean in practice?
It just means the expander isn't supplying power for the signal. It's passive. It just waits for an external switch to close or open. So you can tie it into almost any existing system. It'll take wire from 26 all the way up to 16 AWG, and it's protected against voltage spikes, up to plus 36 VDC.
That's pretty robust. Now, 16 general inputs that's a lot. But here's the detail that really stood out to me. There's a specialized, dedicated screw terminal pair right next to them, just for a tachometer. Why bother with that? Why not just use a standard input?
Well, it's about moving from reactive to proactive. A simple binary sensor tells you a fan failed after it stopped. A tachometer measures its speed.
I see.
It accepts frequencies up to 255 hertz, so the system can actually detect when performance is degrading, like a fan that's spinning too slowly before it fails completely. It's about system health.
Okay, so once the system detects that problem, the fan is failing, we need to do something. And that brings us to the output side.
Exactly, the control mechanism. This V2 model uses 16 normally open SPST relays, single pole, single throw. You get 16 screw terminals to, switch things on and off remotely.
So you monitor the fan with the input, and you can trigger a backup fan or an alarm system with the output.
Precisely.
And what kind of power can these handle?
The ratings are pretty respectable for this kind of device. You can switch up to 16 different things, rated up to 125 VAC at half an amp, or 30 VDC at a full amp. It's enough for most signaling equipment.
Lights, low-power circuits, that kind of thing.
Yeah. But the real gold standard here for reliability is that these outputs are galvanically isolated up to 1 kV.
Okay, galvanically isolated. Break that down.
Think of it like a dedicated buffer. It prevents a short or a voltage spike on the device you're controlling, say a faulty silent, from feeding back and frying the very sensitive monitoring electronics.
Right. It protects the main brain of the system.
It's vital, yeah.
Yeah.
Especially in a multi-million-dollar server environment.
And linking this all back to that simplification idea we started with, how does this whole thing connect?
It's just that single RJ45 sensor port. It supports CT5, 5E, or 6 cable, and the runs can go up to an incredible 500 feet.
500 feet? That's, over 150 meters? That is a serious range.
It means your monitoring system doesn't have to be physically anywhere near the equipment. And, for the business side of things, it's TAA compliant, priced around $300, and it comes with a 2-year NTI warranty. All solid specs.
So when you boil it all down, the real insight for you, the listener, isn't just the spec sheet. It's the ability to replace potentially 32 separate messy wiring runs with one single long-distance network cable.
And with that, you get 16 environmental inputs, that really clever tachometer input for predictive maintenance, and 16 discrete isolated control outputs, all consolidated.
It's a huge simplification.
Which leaves you with something to think about. Given this massive I/O capacity and the ability to run that single connection 500 feet, how might a system like this change how we think about monitoring complex environments that aren't in one room? Maybe integrating security, HVAC, and power across multiple separate buildings on a single campus.